Now, what is a ratio? I'm going to start with a definition. Then we're going to go on to examples. Then we'll talk about simplifying ratios, okay? So a ratio is a way of comparing two or more similar qualities. Now, that is very important. They have to be similar, okay? What I mean by that is they have to use the same measurement. Okay, we can use it to compare costs, weights, sizes, and other quantities. But remember, they have to be in the same unit. So let's look at our example here. Say, suppose we have a model boat. So that's one of those small boats that shows you how the big one looks like. Okay, we have a model boat, and this model boat is 1 meter long. Whereas an actual boat is 25 meters long. When you write this in a ratio from model to the length of the actual boat, this is 1 to 25. So that's how you say it, okay? We write it with a colon in the middle. Then you write the first digit on the left and the other on the right. Okay, so the way we say it is it's 1 to 25. Now, take note, because these are in the same unit, you do not include units in a ratio. Okay. So you do not, okay, I see someone is trying to record. Remember, this recording is available on the Google Classroom. So you do not have to record independently, okay? Right, so no units are included because we already assume that they are in the same unit. So if they give you dimensions of the boat in centimeters, then the model will also be in centimeters. Okay, that's how it works. So I'll come back to simplifying ratios now. Okay, no, I have to do it now, never mind. Simplifying ratios is just a rule that we have about ratios. You always write it in its simplest form. Now, if you look at 4 and 2, do you guys see a common factor between those? 4 and 2, do they have a highest common factor? They do have a common factor. What is the highest one? Debajo says yes, which is correct, and it's 2, okay? So then you're going to go and divide 2 by 2, and 2 goes into itself how many times? Once, and into 4 twice. So the reason we do this is you always represent ratios in their simplest form. Okay, now the important thing to know about ratios is it does not necessarily mean there will be 2 ounces of flour and 1 ounce of fat. That just shows you the relationship. So ratios are all about the relationship between stuff. Okay, it doesn't necessarily mean that's exactly how many they are. So what it means is for every 1 ounce of fat, you will have 2 ounces of flour. It doesn't mean there is 1 and there is 2. No, it means for every 1, you will have 2. So for instance, if I say, for every 1 sweet I give myself, I will give Logan 3, right? So let's say these are sweets. So this is me, and this is Logan, and this is the ratio. So if I have 2 sweets, how many will Logan have? For this specific example here, if I have 2 sweets, Logan will have how many? Guys, this is a ratio. I said for every 1 sweet that I take myself, I give Logan 3. So if I have 2, that means Logan has how much or how many sweets? 6. Do you guys see how a ratio works? So it does not necessarily mean that we have 1 and 3. We could have 2 and 6, or we could have 3 and 9, or we could have 4 and 12. It just shows you how the sweets are divided. Do you guys understand this? So that's what a ratio is, but you always write it in its simplest form. Okay, we always write ratios in their simplest form. Now, if you have a ratio between fractions like we have over here, okay, so I have a quarter to 5/8. All right, so the first thing we're going to do here is pretend we're adding them. So we're going to find the lowest common denominator. So I want these both to have the same denominator. And in this case, they made my denominator 8. Okay, so then I have 2 over 8, 2, 5 over 8. Once you reach that stage, you can get rid of the similar denominator. And my simple ratio is just 2 to 5. Okay. Enough talking from me. Let us see these ratios in their simplest form. So firstly, you just write what they're telling you, okay? 2 to 10 means you write a 2, you write a colon, and you write a 10. Now, between 2 and 10, do they have a common factor? 2 and 10, do we have a common factor here? Yes, what is the common factor? It is 2. So 2 goes into itself how many times? Once, and into 10, 5 times. So then the simplest ratio would be 1 to 5. Okay, let's do B. 80 to 20. First, I'm just going to rewrite it with the original numbers. Now, what is the highest common factor? These two have a lot of common factors, but what is the highest one between 80 and 20? Let's hear. The highest common factor between 80 and 20. Anyone? What is any common factor then between 80 and 20? 10. Yes, 10 is one of the common factors. So if I divide this by 10 and I divide this one by 10, then my new ratio is what? What's 80 divided by 10? It is 8. And 20 divided by 10 is 2. But do they still have a common factor? Now we are down to 8 to 2. Yes. So what is the common factor between 8 and 2? It is 2. So then I can go again and I divide each of them by 2. And then 8 divided by 2, what is my new ratio? 8 divided by 2. Thank you. My new ratio is 4 to 1. Can we simplify this any further? Do you guys think we can simplify this any further? No, we can't. Okay, we're done simplifying. Now let's see what's happening by 6. C. We have a fraction here. Okay, so I have a third to 1, which can be written as what? How can I write 1 as a fraction? How can I write 1 as a fraction? 1 over 1. Beautiful. Now, of course, I'm going to write 3. 1 over 1, not 3. Now, we want these two to be the same denominator. So what am I going to change my denominator to? What's the lowest common multiple between 3 and 1? My lowest common multiple. Now we're doing multiples, not factors. What is the lowest common multiple between 3 and 1, guys? It's 3, right? So I'm going to have 1 over 3 here. And then instead of 1 over 1, what is my new fraction going to be on the side? Instead of 1 over 1? No, remember, once you find the denominator, you're going to times here by 3, but you also have to times the numerator by 3. Otherwise, you're changing the meaning of the fraction. So then what is my new fraction once I have applied this? It's going to be 3 over 3. So once we have the same denominator, once again, we can get rid of them. So then my ratio is 1 to 3. Okay, thumbs up, thumbs down. We were awfully quiet here, so I'm a little bit worried. Thumbs up, thumbs down. Did you guys understand what we just did now, simplifying ratios? Did we understand? Can I get any reaction? Thumbs up, thumbs down. Thank you. I only have 2. Everyone else? Thank you. Much better, ne? Much better. Okay. Now we're going to do the same thing. In a class, there are 15 girls and 12 boys. What is the ratio of girls to boys? Okay. So in the first place, we have 15 to 12, but this is not my simplest form of this ratio, right? So can you guys tell me what the lowest common factor, highest common factor is? What is the highest common factor between 15 and 12? What can we divide both of these numbers by? 3. So I'm going to divide both of them by 3. So then my actual ratio is 5 to, what's 12 divided by 3? Nice, 5 to 4. So the ratio is 5 to 4, but it doesn't mean there are 5 girls and 4 boys. It just means for every 5 girls, there will be 4 boys. Okay? Johan Johan walks 2 kilometers to school and Tabang walks 200 meters. Write the ratio of Johan's distance to Tabang's distance as a ratio in its simplest form. Now, we have a problem here with these two. What's the problem? Between the distance of Johan and the distance of Tabang, what problem do we have between those two? The units. We are in different units. So we have to convert one of these guys to be in the same units. So how do we go from kilometers to meters? How do I go from kilometers to meters, guys? I have no idea what that means, Teboho. What am I multiplying by? I'm going to say 2 times. Kilo means? How much is kilo, guys? Oh, I should have put a conversions table here for us. Are you sure it's 100, Ronnie? Are you sure? Kilo means 1,000, guys. We need to learn this, 1,000. So then, how many meters is 2 kilometers? How many meters is 2 kilometers? If I'm multiplying by 2, that means I will have 2,000 meters. Okay, now we have the same units, so we can compare them. Okay, so Johan's distance is 2,000 meters to Tabang, who is 800 meters. What is the common factor between 2,000 and 800? 2,000 and 800. Can you guys come up with a common factor between those two? First, we can divide by 100. Thank you, Asanda. I was going to say the same thing. First, we can divide by 100 to simplify these numbers, right? So I'm going to go ahead and divide both of them by 100. What's 2,000 divided by 100? Thanks, Teboho. We're getting there. What's 2,000 divided by 100? Get rid of these zeros, and it gives you 20 to 8. Okay, now what is a common factor between 20 and 8? What can go into 20 and into 8? 4. So I'm dividing both by 4. And my last final ratio is what? They've already sent it to me. It is 5 to 2. Okay. Okay. Now let's simplify these. Express the following in its simplest form. So we're just finding the common factors and simplifying. 18 to 20 to 12, excuse me. Common factor quickly. Common factor between 18 and 12. 6, nice. Okay, so then 18 divided by 6 is, wait, that is a common factor, but it's not the highest one. So you would have to do it again. You would have to divide them again. But it's fine if you do 2 steps. We've been doing it the whole time. Okay, thanks, Deborah. That's 3, and 12 divided by 6 is? You're welcome. 12 divided by 6 is 2. Done. Number 2 is 24 to 32. Common factor. 24 and 32. I almost told you the common factor. That was very close. 8. Nice. Now 24 divided by 8 is 3. And 32 divided by 8. Nice. 4. Okay, next. Okay, I want us to do number 5. Let's do number 5. 9 to 15 to 21. Now you have to find a number that goes into all three. So what would you say is a common factor between 9 and 15 and 21? It's 3. Nice. That is a common factor. Okay, so 9, I'm going to divide by 3, divide by 3, and divide by 3. Now what's 9 divided by 3? It is indeed 3. 15 divided by 3. So this is 3, 2, 5, 2. What's 21 divided by 3? 7. Nice. Now, I want us to look at number 7 very carefully. There's something important that we're going to learn over here. Okay? We are not allowed to have decimals in my ratios. Okay? So here, this guy over here is a problem. Okay? No decimals in ratios. Okay? So how are we going to fix this decimal? How am I going to turn this decimal into a whole number? Do you guys know? I want to turn my decimal into a whole number. Does anyone have an idea of how I would do that? What can I multiply 1.6 by to make it a whole number? Think of moving commas. We did it in the previous lesson. I want this comma to go over there. So how am I going to multiply this? What am I going to multiply this number by? By 10, guys. If I say 1.6 times 10, is this comma going to move left or right? Will my comma move left or right, guys? 10 to the power of 1 is a positive exponent. And remember, we're doing the reverse. So it's moving right. So then it's going to be 16. But what I do on the left-hand side, I have to go do on the right-hand side. So if I times 1.6 by 10, then I have to times 1 by 10. And what is 1 times 10? 1 times 10 is 10. So then my new ratio is 16 to 10. Now we can look for common factors. Do we have common factors between 16 and 10? Do we have common factors between 16 and 10? Yes, which is 2, right? So I'm going to divide this by 2, divide here by 2. And now I have 16 divided by 2, which is 8, to 10 divided by 2, which is 5. Can we simplify this any further? No. So then we are done with this one. Okay, let's do number 8. It's also another decimal, almost said fraction. This time we have 0.36 to 0.06. If I times these by 10, is it going to solve my problem of decimals? Do you think timesing these by 10 will solve the problem that I have of getting rid of decimals? Anyone? Debajo says yes. Okay, let's see. 0.36 times 10. It's going to move right once. Debajo's on to me. It's not going to solve the problem. So what do I have to multiply it by? Not by 10, but by? How many times do we want this to move? Nice. Asanda by 100. Okay. So then what's 0.36 times 100? 0.36 times 100. That's 36. But what I do on the left, I have to go do on the right. So what's 0.06 times 100? Just 6. So then my ratio is 36 to 6. What is my common factor between 36 and 6? It is 6. Okay? Divide by 6 on both sides. So then what is my final ratio over here? I've divided by 6 on both sides. Nice, stable whole. 6 to 1. Okay, I think that's enough of that. Thumbs up, thumbs down. Do you guys understand how to simplify ratios? Okay, that's a bit more thumbs up. I feel better. Okay. Now, we're going to do something different. Ratios can be used to share or divide quantities, any quantities. So it says quantities of money, weights, and so on. Okay, so this time you're going to be given the simplified ratio. You're going to be given the money, and then you must divide it. Remember, I said a ratio just tells you how you are dividing this money. It does not tell you how much each person has. Okay, so Mrs. Sharp and Mr. West each share an inheritance of 64,000 in the ratio 5 to 3. How much do they each get? Okay, so I want you guys to look at this egg, okay? Pretend this egg is 64,000, the whole egg, right? So we're going to split this in the ratio 5. Sharp is going to get 5, and West is going to get 3. So in total, you have to add this ratio up, okay? So if this person is getting 5 parts of the ratio, and this one is getting 3 parts of the ratio, in total, how many parts does this ratio consist of? If one person is getting 5 parts and the other one is getting 3 parts, then in total, together, they're getting 8 parts. Do you see? That's where this adding comes from. All right. So let's take it from here. What happens after we know how many parts in total this has? Does anyone know? Nice. We're going to divide by? Oh, but that's timesing and dividing. But I get what you mean, Tebogo. So you're going to take the total amounts that they have. And for sharp, you're going to say times how much, what's the fraction that sharp gets? He gets 5 out of 8. Do you see why we divide timesing by 5 over 8, guys? It's very important to get this. There are two ways to do this actually, but I'll do both of them just now. So you say times 5 over 8. And for west, you're going to do the same thing. Thank you very much. 40,000. Okay, 64,000 times west gets 3 out of 8. And that's going to give us, I'm assuming, 24,000. Okay, guys. The other way to do this is to start with the main amount. Okay, so you say, I have 64,000. Now I want to know how much one part is. Now, if this 64,000 is 8 parts, then I can just divide it by 8. Do you guys see where I'm coming from? So then one of these parts will be worth 8,000. This is one part. Okay, now we know that sharp is going to get 5 of these parts. Okay, so he's going to get 8,000 times 5, which leads us back to the 40,000. And we know that west is going to get 3 of these, which leads us back to 24,000. Now, you guys can do this either way you prefer, okay? This is 5/8 of 64,000. What does of mean? What operation do we use when we say of? A third of something. It's multiplication. Okay, so does this make sense where this multiplication comes from? So we're saying you're getting 5 over 8 of 64,000, and this one's getting 3 over 8 of 64,000. Whereas on this side, we're saying, let's find out how much one part is worth, and then we'll see how much each person gets. Okay, thumbs up, thumbs down on both of these explanations. If there's something you're not sure of, speak up now. Okay, I have 2 thumbs up. 3. That's better. Okay, so you guys will choose whichever one you're comfortable with between these two. Okay, now let's get going. Divide 72 in the ratio 3:4:5. First step, we have to add the ratio, right? No matter what, we have to add this ratio to find out how many parts in total we have. So the first person is getting 3 parts, plus 4 parts, plus 5 parts, and in total, that means we have how many? What's 3 plus 4 plus 5? That is 4, that is 12 indeed, okay? Then method 1, we say 72 times. Person 1 is getting 3 out of 12. Person 2 is getting 4 out of 12. And person 3 is getting 5 out of 12. That means the first person is getting how much? 72 times 3 over 12. Nice. 18. The next one is getting 24. And the next one is getting 30. Whereas with method 2, you would have said 72 divided by 18. This is what's going to give us a 6. No, by 12. Why am I saying 18? This is going to give us 6. right? And then you say, so for person 1, that will be 3 times 6, which is 18. For person 2, it's 4 times 6, which is 24. And for the last person, it is 5 times 6, which is 30. Okay, so let me write here. These are two of the same thing. This is just method 1. And this one is method 2. Okay. Next one, we're doing the same thing. Divide the following numbers in the ratio 1 to 5 to 5. All right, step 1 is we're going to add this. Okay, that's step 1 for all of the questions. So I'm going to add it up here. 1 plus 5 plus 5, and that gives me how much? 11. So in total, we know we have 11 parts, right? So in the first one, okay, so for the first one, I'm going to use method 1, and then method 2, and then method 1 again. So for the first one, I'm going to say 11 times 1 out of 11 is, then 11 times 5. I don't know why I'm saying 2. 5 out of 11. And the last one will be 11 times another 5 out of 11. So how much is the first person going to get? Nice, thank you. 1, 5, and 5. With this one, I'm doing method 2. So I'm going to say 33 divided by 11. How much is 33 divided by 11? 33 divided by 11. That is 3. So one part is worth 3. So then the first person will get 1 times 3. Second one will get 5 times 3. And the last one will get 5 times 3. So the first one gets how much? What's my answer for the first one? 3. Then 5 times 3, 15. And another 15. Okay, for number 3, I'm going back to method 1. I'm going to say 253 multiplied by 1 over 11. 253 multiplied by 5 over 11. And again, 253 times 5 over 11. Let's get going with this one. 253 times 1 over 11. That is how much? 253 times 1 over 11. Nice. Thanks, Deborah. We have 23, 115, and 115. Yes. Okay. So remember, if you want to check your work, you must add the answers up. And they have to give you the original number you had. Okay, so let's check here. 5 plus 5 plus 1 is 11. That is correct. Okay, 15 plus 15 is 30. Plus 3 is 33, which is what we had in the first place. 115 plus 115 is 230 plus 23. That's 253. And that adds up. So if you're not sure if the calculation you did was correct, just go back and add them. And if it doesn't add up to your original number, then you know that you did something wrong. Okay. Okay, before we get to the difficult ones, let's see. We're dividing once again. So again, I'm going to add at the top because that's step 1 for all of them. 5 plus 3, which is going to give us 8. This one time I'm going to start with method 2. So I'm going to say 80 divided by 8, which gives me how much? 80 divided by 8 gives me 10. So the first person is going to get 5 times 10, and the next one is going to get 3 times 10. And that is 50 and 30. Do they add up to the original number? Yes. 50 plus 30 is indeed 80. Okay, next one. 176 times 5 over 8 and 176 times 3 over 8. What's 176 times 5 over 8? What do you guys think? 176 times 5 over 8, 110, and 176 times 3 over 8, 66. Do they add up to 176? Yes, they do. So then we did the correct method. Then we get to the last one, number 3, which is going to be very interesting just now. 100 divided by 8. What is 100 divided by 8? 100 divided by 8, 12,5. That's true. Okay, now let's do our calculations. 12,5 times 5 and 12,5 times 3. What's 12,5 times 5? Anyone? 12,5 times 5. Okay, I'm going to take out my calculator and do it myself. There we go, 62,5. And 12,5 times 3, 37,5. Can we leave these as decimals? Can we leave these as decimals? Think carefully before you answer. Yes, we can. Thank you, Deboho. Only the ratio can't be decimals, but we can leave these as decimals. And do they add up to 100? Let's see, 62. Yes, they do. All right, thumbs up, thumbs down so far before we go into a little bit more challenging. Nice, thank you. Thank you, guys. Okay. Now we go into dam. The perimeter of a triangle is 280 meters. The ratio of its length to its breadth is 5 to 2. Determine the area of the triangle. Now, guys, is the length is the length 5 meters long? We can see we have a ratio there. Is that length, does that mean that the length is 5 meters long? What do you guys think? Afani says yes. Think of what a ratio is. Does this mean that the length is 5 meters long? Can I have more responses, please, than Alfani? No, says Dewaho. No, guys, this is just the ratio, remember? Remember, it can't be 5 because perimeter is what? 5 plus 5 plus 2 plus 2. Is that equal to 280? No, this is equal to 14. So the length can't be 5 and the breadth cannot be 2. Okay, so in the meantime, while we do not know how many times we have to times this ratio, what happens in maths when we do not know how many times we're timesing with something? If we do not know a number, what do we do? If I'm working with a number, but I don't know what that number is, what do I do? Not necessarily. Asanda, is that a multiply? Or are you saying what I want you to say? I'm not sure if you're saying what I want you to say or if that's a multiply. What do we do, guys, if we do not know what a number is in mathematics? Nice, we give it a variable. Now I'm gonna give the ratio, what we times the ratio by, a variable, right? So let's say the length will be 5 times the variable, which we don't know, and the breadth will be 2 times that same variable. Does this step make sense to you guys before I even move on? Thumbs up, thumbs down on this step of 5x and 2x. Only 2 thumbs up. You're making me nervous. Tebogo, think about this, right? So remember this ratio, the length could be 10. Do you agree with me, Tebogo? Which means it would be 5 times 2. But now we don't know what we have to multiply by, so I'm just going to call it x for now. But in a ratio, whatever we times on the right, on the left, we had to go and times by the right. So if I'm calling this one x, the one on the right has to also be x. Have I clarified? The problem is we can't actually multiply by anything because we have no idea what we are multiplying. Okay, you said thank you, so it means you're good. Okay, so it's 5x and the breadth is 2x. So how many lengths am I adding and how many breadths am I adding for the perimeter? Remember, they told us the perimeter, right? How many lengths am I adding and how many breadths am I adding? 2. Thank you very much. So 5x for the first length plus 5x for the second length plus 2x equals 280 meters. Do you understand why I made it equal to 280 meters? Is there anyone who doesn't understand that part? We're all with me with why I made it 280 meters. Okay, because we were told that's the perimeter. Okay, so 5 times something that we know, plus 5 times something that we don't know, plus 2 times something that we don't know, plus 2 times something that equals 280. Now I have a bunch of x here. What can we do with these? What can we do with this left-hand side? Add them because they like terms. So what's 5x plus 5x plus 2x plus 2x? How much is that? 14x. Thank you. So then 14x equals 280. So how are we going to find out what this x is? We're still looking for x here. Divide. Okay, these 14s will cancel out. So therefore the x will be 20. Are we done here? Did they ask us for the number we're going to multiply x by? No, they asked us for the area. But before we even get there, guys, we said the length is how long? Is the length x? Go back to the ratio. Was the length x in the original? Thank you, Tebogo. Beautiful. We have to substitute. Now we know that x is 20. That means my length, which was 5x, is 5 times 20. And that is how much? The length is 5 times 20, which is anyone? That is 100, right? And my breadth is 2 times 20, which is how much? 40. And how do we work out area again of a rectangle? They gave us perimeter, but they're asking us for the area. Length times breadth, which we now know is 100 times 40. And what is 100 times 40? 100 times 40. Nice. 4,000 meters. Okay, and if you're not sure about these guys, just add them and see if you get 280. Okay, 100 plus 100 is 200, plus 40 is 240, plus another 40 is 280. So we did the correct calculation. Okay, thumbs up, thumbs down on this. Thumbs up, thumbs down on the specific calculation. If there's one place where I've lost you, say so I can help you. Don't be shy. This was a nice problem-solving question, eh? Beautiful. Beautiful, beautiful, beautiful. Okay, this is my last example before we leave. We're making a fruit salad at a restaurant. Okay, she uses piece of fruit in the following ratio. So, banana to apple to pawpaw is 1 to 2 to 3. Now we are being told that she uses 20 pieces of apple. Are you with me? So the ratio is 1 to 2 to 3. Now they are telling us this guy over here is actually 20. How will I know how much apple and how much, how much banana and how much pawpaw she uses? How did I get from 2 to 20, guys? Let me do this. This is X, this is 20, and this is Y. How did I get from 2 to 20? Remember, whatever you do in one place of a ratio, you do everywhere. That's your clue for this one. So how did we get from 2 to 20? We either times though we divided by something. Nice, we times by 10. So then to go from the first ratio to the next one, we're assuming that we are timesing by 10, which means for bananas, it will be 1 times 10. And for pawpaws, it will be 3 times 10. So then how many bananas is he using? 10. And how many pawpaws are we using here? 30. Do you guys understand this? This is purely thinking and strategizing. Okay. All you need to remember is whatever I do for one of the ratio numbers, I have to do everywhere. So if I times by 10 for one of them, I have to go and times by 10 for all of them. Okay. Next says if she uses 12 pieces of banana, how many pieces of apple and pawpaw should she use? So I'm writing this ratio in order again, 1 to 2 to 3. Now we know this one is 12, and I want to know X and Y. How did I get from 1 to 12? How did I get from there to there? Anyone? I times by 12. So then I have to go times by 12 everywhere, which means I'm going to have to go say 2 times 12. So that means how many apples are we using? We're using 2 times 12. We're using 24 apples and 3 times 12 pawpaws. That means we're using 36. Nice, guys. I'm going to end the lesson here for today.